The other day, I was giving a talk to some of my mentees, and the topic of my early career and the question around how do you keep pace with the changes in technologies came up. At the start of my career, I was a mainframe programmer. And this is a throwback to more than 25 years ago to the Y2K and kind of made me reflect on the whole Y2K era. For those of you who remember, Y2K was a big issue because the world was running the mainframes in the 80s and 90s. And the mainframes were programmed in a way that programmers wanted to conserve data space, which meant that many of the fields were kept as 2-digit instead of 4-digit year. So the prediction was at the end of 99, the year 1999, when the computers would switch to 2000, they would switch to 00. And when the year was 00, the computers could go haywire. The systems running banking, finance, insurance, and pretty much everything, even to avionics, would come to a grinding halt. So a huge cadre of technologists was mobilized, had to learn mainframes and learn to support, maintain, and modify the code such that it would get us past that catastrophe. And looking back, yes, we did move past that hump. Very few major issues, and year 2000 came, 2001. We have seen waves of changes in the technologies. But the lessons that I learned way back then, early on, and the grounding in the basic programming principles of system design, continue to hold even today. Like if I look at a few basic principles around, say, OLTP versus batch processing, online transaction processing, managing real-time users interactions, and developed using technologies like CICS and MVS were the backbone of OLTP. And those have evolved. Technologies have changed tremendously now. Now it's all web-based, mobile computing, but the grounding in OLTP continues to be the same. Similarly, the batch processing, handling bulk data operations, processing large files, datasets, databases, and the jobs that were scheduled using JCL, the schedulers, and managed by different schedulers. The technologies have changed, but the basic principle around job scheduling, the basic job batch processing continue even today, right? Even in the newer systems and technologies. The same with data interchange. Initially, it was all batch transfers, and then came modern FTP engines, and then EDI for machine-to-machine communication. All that evolved into API gateways, XML messaging, and modern EDIs for a more dynamic data interchange. Now, the other thing that continues to evolve is the reporting and analytics. Early systems ingested large data sets into reporting databases, which later evolved into data warehouses, data marts, and structural analysis of data. But the data, large troves of data from disparate systems aggregated into data warehouses and data marts. The guiding principles defined then continue to hold ground even today, although they evolve. Security. Early mainframes used RACF, Resource Access Control Facility security technology. They were impenetrable for that time. They were pretty solid, robust. Now, some of the guiding principles designed around access control, authorizations, continue to evolve even today, continue to be the guiding principles for the newer technologies even today. So, what has changed? Scalability of systems has changed tremendously. What was a closed loop system for maybe 80,000, 50,000, 40,000 users within a corporate ecosystem has now been opened up. millions of users from around the globe access your systems today. New performant hardwares have evolved and moved to the cloud. Technologies have changed. Now, the risk from network open to the wide internet has evolved tremendously. Now, while all that is changing, over 70% of the Fortune 500 companies still run Z systems, IBM Z systems, mainframes, which means over 30 billion transactions still flow through IBM Z systems, including 400 million retail transactions. And these systems are still used by 60 to 70% of Fortune 500 companies. Many of the government systems, including the federal government's IRS, state government systems, revenue systems, systems running social security, the engines behind those are still mainframes. And just looking at, say, LinkedIn, you can still see job postings for mainframe architects, mainframe programmers, mainframe analysts. So while the backbone continues to be there, the technologies continue to evolve. So the lesson here is pretty straightforward. The grounding that you get early on in your life, in your programming life, in your system analysis life, will continue to be the grounding that you build on. So that's the